Looking to buy a Commodore computer? Have one already? Here is a guide to the type of components you need to compute like it's the 1980s. Welcome. Were you there in the 1980s when you bought your first Commodore computer? You pulled it out of the box, hooked it up to the television set, grabbed the system manual, opened it up, and began typing your first program. This program here is actually found on pages 7-28 to 7-29 of the Commodore 128 system manual. Well, it's the mid-2020s, and perhaps you've been using Commodore emulators for years. And maybe once in a while you've thought about getting into real Commodore hardware. There are some challenges that you will face if you want to do so. In this video, I will identify a few of the challenges that you will face and what kind of components that you need to overcome them so that you can compute like it's the 1980s all over again. Let's examine two ways in which we can get started. Let's begin with the first. Now, hang on. On second thought, maybe I'll start with the second way. However, this teaches us a lesson. Unless you meet the system requirements, things are not going to work. For example, if we were to buy a Commodore computer and simply plunk down an old monitor that we have and try to plug it in, we're going to find out it's not going to go very smoothly. This journeys us to our first roadblock, video display. Of course, in the 1980s, getting compatible hardware was a lot easier. You can just see an example here in this One Run magazine of June 1987. All the various ads for the different hardware you can get for your Commodore 128 or your Commodore 64, all you had to do was buy it and plug it in, and it just worked. Now, the only real challenge back in the day was how much you had in your wallet, because there was a lot of Commodore hardware in abundance, not just in the magazines, but in your local stores. Hey, here's an article by David Bradley. Anyways, getting back to video displays. Without getting an additional monitor, you might already have the means of displaying what your Commodore is showing. Perhaps your television set still has the old coaxial cable connection. I have found that the old TV/computer switch boxes have not really aged very well over time. Every one of mine has gone bad over the years. They must have corroded inside, but I found an alternative way to use the RF out to make a connection to your television set by just using one of these coaxial to RCA connector converters. Just screw it into your normal coaxial cable and then plug the RCA end into your Commodore, and then the other end just screw it into your TV set just like you would cable TV in the days of old. And voila! Here you can compute like it's the 1980s just with a display that you might already own. The negative side to this, though, is that the RF out display port is probably your poorest way of viewing what the Commodore computer is displaying. For the gold standard in displaying what your Commodore computer is outputting is a genuine CRT monitor that can do composite video or as video, which is good for the 40 column output of a Commodore 128, or you can get a dual monitor such as this 1902A, which is also capable of receiving the VDC or 80 column output of the Commodore 128. You don't necessarily need a Commodore monitor to do this, but if you do get one that you want to display the VDC video, make sure that it's capable of rendering RGBI video, digital RGB. Although this is the gold standard for these type of machines, getting a working CRT monitor from that era is getting harder and harder to find. They are rare, they are also expensive. So what is the next best thing you can do? Well, you can acquire one of these video converter devices. Here on the side you have from your Commodore composite in, VGA in, and S-video in. If we turn this unit to the side, this side, your VGA monitor will then connect to this port. Of course, there are various controls on the front. And this will take care of your composite video output needs on your Commodore computer. However, for the Commodore 128, you also have the VDC or 80 column output. What you need to get is one of these RGBI output to VGA converters. So you see on this side is the part that goes into your Commodore 128, and this side is the VGA out part. Now this particular model, actually I've seen all models, they require a 5-volt input from a different source. On the VGA part of this device is a 15 kilohertz output. Now you can find 15 kilohertz monitors, VGA monitors, but those are also difficult to come by. So what you need to have is one of these scan doublers. What it does is it puts it into frequencies that are understood by modern VGA monitors. Now integrated into this board is a 5-volt out connector which connects to your RGBI to VGA converter. So let's assemble this unit by plugging the converter in and flipping it around. Let's connect one end of a power cable into the 5-volt out, and we'll plug the other end of this cable into the 5-volt in your RGBI to VGA converter. And now this is how this puppy looks all assembled. All that's left is to plug in our 128 to our VGA monitor. And voila! Now we're ready for all the modes on the Commodore 128, both 40 column VIC mode and 80 column VDC mode. Just a side point here, the cable that I used to plug the Commodore 128 into the RGBI to VGA converter is just a standard DB9 modem cable. Now if you're going to go this route, make sure you do not use a null modem cable. That will not work in this configuration. Or you can just use a real, genuine RGBI monitor cable. That will work as well. Now that we've gotten around our first roadblock, that of our video display, let's move on to the next roadblock, audio output. Now this roadblock isn't much of a challenge if you have managed to acquire a genuine CRT monitor for the VIC output, because on those monitors the speakers are already built into the monitor. Likewise, if you were going to use the RF output of your Commodore computer, the audio signal and the video signal are all passed through the same cable. So on your television set, not only will you see the video, but you will also hear the audio coming through as well. However, if you were not going to use this solution, if you need to use some of the converters that we've already gone through, you will need a cable that allows you to connect a PC speaker or a stereo to your cable that runs out of your composite monitor port on your Commodore computer. Now here is just such a cable. I got this off of eBay a few years ago. Let's just take a look at some of the connectors. Here is your 40 column connection, your composite that goes into your Commodore computer. Here is S-video out for an S-video monitor. Next is your composite connector for a composite monitor. And here are two audio out. It actually takes the mono signal from your computer and splits it up so you can connect it to a stereo speaker system. Now you may need to have an adapter depending on what you want to plug it into. So now this takes your RCA output and changes it to a 2.5 millimeter output so that you can connect it to a computer speaker, for example. That wraps up our audio roadblock. Coming up next, storage. In the 1980s, the most popular forms of storage for your Commodore computer was cassette tape, 5 1/4 inch floppy diskette, and later the 3 1/2 inch floppy diskette. The hardware required to drive the various forms of media shown was, for the cassette tape, the Commodore C2N or 1530 dataset. Now this could be used for virtually all the 8-bit lines of the Commodore machines, such as the Commodore PET, VIC-20, with an adapter the +4, with an adapter the Commodore 16, the Commodore 64, the Commodore 128. And there were different styles of the C2N dataset, but every one of them was compatible with each other. For the 5 1/4 inch floppy disk, again, Commodore made a wide variety of disk drives. For the Commodore PET, they had dual drives. The Commodore 1541 was probably the most popular 5 1/4 inch floppy disk. Prior to that was the Commodore 1540, which was made for the VIC-20. The Commodore 1551 was made for the Commodore +4 and Commodore 16. And the Commodore 1571 made for the Commodore 128, the one that's pictured here. For the 3 1/2 inch floppy disk, the Commodore 1581 was built. And there was also a 3 1/2 inch floppy built and designed for the Amiga computer as well. What you might be wondering at this point is, what really is the storage challenge here? If you know where to look, picking up cassette tapes, floppy diskettes, data sets, and floppy disk drives is easy enough, if you have the money to do so. The challenge is this: how can you get software onto and off of cassette tapes and floppy diskettes? Let's begin with putting software onto and taking software off of a cassette tape. Let's build something really simple, because the cassette tape is actually the slowest form of storage media, well, aside from just using the keyboard, that there is available for your Commodore computer. We'll just do a simple hello world here on the VDC display. Okay, so that verifies it's working. Let's stop and clear the screen, and let's save this puppy to cassette tape. Hello world. Press record and play on the drive. So what's important here is to see where on the counter it is where you're saving so that you can retrieve your program quickly. Alright, it's ready. Let's see that this is saved properly by doing a verification. So verify hello world. Press play. Searching. Found, verifying, and it's good. Aren't you glad we used a short program? Resetting and loading. Now that I've reset the computer, it no longer has the program in memory, so let's load it again from tape. Now I chose to do this on the 80-column screen so that it doesn't blank out during the process. That's something that's kind of annoyed me. Alright, list. It's all there. And that's how we did it in the 1980s. But the question is, how do we move this file that's on tape onto a PC? And how do we get a file from a PC onto cassette tape? Simply put, we take our dataset and plug it into a PC. But we have to use an adapter, such as this 1530 USB adapter. You plug it into your cassette's cable, you take it over to your PC, set her down, grab the USB end of the dongle and plug it into a free USB port on your computer. And voila, you're ready to go as far as hardware is concerned. And you must use an audio capture or editing software such as Audacity. Make sure you select the USB microphone, select mono, press record, hit play on the dataset, and watch as the program comes in. So this is a short program, so it won't take very long. And you can tell when it's finished when you see that the audio goes blank, when it flatlines. And here we are finished. So now at this point we want to save the file as a WAV file. And that's important because when we use the audio tap program, we can convert it to a TAP file so that it can be stored or used by perhaps a Commodore emulator such as the Vice emulator. So let's just give this file a test. Found it, that's good news. Okay, let's list this. It's all there. Perfect. It's just that easy. Now this method doesn't have to be limited to just one file on your cassette tape. You can image an entire tape using this very same method. Just allow it to go from beginning to end and capture it and convert it to a TAP file, and voila. Now from the PC, let us transfer a tape image to cassette tape. You know the scenario. You have a strong urge to play your legally acquired copy of Master Chess, but you just can't find it anywhere. So you go to a site that archives tape images, grab your copy of Master Chess, and then you wish to play it, but you want to play it on your real Commodore computer. So what do? With your dataset connected to your PC, you grab a blank cassette, pop it in, then you fire up the audio tap program and you leave the settings on default. You press the open button, you select your file, but you don't press the open button yet. First you hit record and play on the dataset, then you press the open button, you wait for the progress bar to make it all the way across and then disappear, you stop the dataset, and you bring your dataset to your Commodore computer. After rewinding the tape, of course. Well then, let's try this. Now that I've got the dataset connected to the Commodore 128, issue the load command, push play on the dataset, and voila, through the wonders of editing, made the whole process faster. I gotta say, I've always appreciated it when a software publisher took the time of making a nice loading screen. And here we are. We see that the process worked flawlessly. And that concludes our section on cassette tape. Moving on to floppy diskettes. And as before, we'll make something easy. So now let's grab a blank floppy diskette and put it into the drive, and let's begin to prepare it, much like how you would prepare a hard disk drive you put in a modern computer today. So we take a directory and we can verify that this disk is indeed blank. Drive not ready isn't always about blank diskettes, but in this case it is. So let's prepare the disk by formatting it with the basic 7 header command. And to spare the agony of going through the whole format process, through the beauty of editing, I've shortened it up again. Okay, so we see that it's now ready to accept data on the floppy disk. So let's write something really quick and basic that we can use as the basis for a disk image to grab off of the floppy and put onto a PC. Now, just so that you know it really is this disk image, I'm just going to put a bunch of garbage in a data statement. There we go. And then you can pause the video and you can compare it if you wish. Okay, so now saving it. Let's take a directory of this. Okay, that's our image. Now, while there are different devices and different methods for getting a floppy disk image into a PC, we're going to use this device. This is a GreaseWeazle. Now, on this side, if we take a look at the ports, this is for your USB cable that goes into the PC. On this side is power for 3.5-inch floppy, and this is where the data cable goes into. So you may have heard of this. And connecting to this device, we're going to use a standard 360K PC floppy disk drive. Now I got this out of an old XT computer. So over here we'll need a power source. We'll talk about that in a moment. And here's where the data cable plugs into. So I've had this for years, and you would be surprised how well this works. And here's the cabling we'll need. So here's the power cable. And this is what I'll use for the Molex connector. So the power cable goes in there. This Molex connector goes into the 5 1/4 inch floppy disk drive. And here is the data cable for your floppy. This part goes into the GreaseWeazle. This goes into the drive. And optionally, you can also at the same time plug in a 3.5 inch floppy disk drive. So the GreaseWeazle is capable of that. Here's a USB cable for your PC. That end goes to the GreaseWeazle. That end goes to your PC. And all put together, this is what the setup looks like. So here is your 5 1/4 inch floppy disk. There is the data cable. There is your power. That goes to the brick. There's the GreaseWeazle ready to go. So without further ado, why don't we push this floppy disk in and let's grab the image from it. Now on the PC, let's tell the GreaseWeazle we want to read from a disk formatted with a Commodore 1571 format. It can also read the 1541, and if you have a 3 1/2 inch drive plugged in, the 1581. But this is a 1571 format, and let's specify the file name, video2024.d71, and let's have it go. Skipping ahead. Perfect, 100%. Now let's verify that this disk image was properly captured. In Vice, taking a directory of the disk image file, the D71, looks good. Load the file demo. List, looks good. Let's run it. Hey, I would say that this image capture was a success. Now going back from PC to floppy diskette. Let's do something interesting here. Let's grab one of those rare Commodore 128 demos. This one's a 40 column. This one's a VDC demo. Let's try this one. Downloading. Great. Now let's put this onto floppy diskette. So this time the format will be a 1541 format because I am applying a D64 image to the floppy disk. And here we go. Skipping ahead. Done. All tracks verified. Now moving over to the Commodore 128. First, let's have a look at what's on this disk. Cool. Let's run the first program. It looks good. Well, how cool is this? On the 80 column VDC display, no less. I would consider this transfer from a D64 single-sided image on a PC to a floppy diskette to be a success. Thus far, all the methods of data transfer that we have discussed will work for any Commodore 8-bit computer. However, the following methods will only work for a Commodore 128. When you pair your Commodore 128 up with a Commodore 1571 disk drive, you can really unleash the power of your Commodore 128 computer. Not only can this floppy disk drive read and write hundreds of CPM floppy disk formats, but it can also read and write MS-DOS or FAT formatted disks. Whether or not it's formatted using MS-DOS, Windows, or even Linux, it can read those disk formats. So the following will show how we can take advantage of this capability. If you have a PC that has a 5 1/4 inch floppy disk, let's first place in a blank diskette and get ready to prepare it by formatting it. If you have Microsoft Windows, this is how we can go about it. Now you might be tempted to format the floppy disk like you would a USB stick or a 3 1/2 inch floppy disk, but you can see it shows that it's unable to be formatted using the GUI method. We still can format it using the command prompt. The format command still contains the elements you need to format a 5 1/4 inch floppy disk. So let's put in the command format, T for tracks, N for sectors, and let's give it the name C128. And let's hit enter and let it format. As you can see, it is quite happily formatting the disk. Let's skip ahead to the end. 100%. Now that's a successful write. Okay, let's check out drive A where the floppy is and take a directory. Perfect. Now let's put a couple files onto this floppy disk. From here on in, we can use the GUI now that the disk is prepared. So let's take these two files out of my documents folder. We'll copy it, go to the 5 1/4 inch floppy disk, and let's hit the paste button once this comes up. Good. Let's hit the home tab and paste. Done. Those files are on that 5 1/4 inch floppy disk. Now let's rename the first file. It's a little bit longer than 8 characters, .3 extension, so that it can be recognized by the Commodore 128's file system. Good. Let's see how it looks using the command prompt. Take a directory. Now that's perfect. This disk is ready to go. Now let's take this floppy and head back to the 128. Copying files on these old systems is always far easier if you have more than one floppy disk drive. So I'm going to add an additional 1571 disk drive to the 128D, which already has an internal disk drive. Shall we proceed? Now let's take our floppy that we wrote on our PC and pop it into this extra 1571. And let's see how it looks if we just took a directory straight out. It's unable to read the MS-DOS formatted disk. However, there is a program called MS-DOS Emulator, which teaches, you could say, or loads a driver that allows the 1571 drive to read an MS-DOS disk. Now that it's loaded, let's take a directory of the disk. Look familiar? There's our files. Now we're able to use this as though it's a native disk on the 128. So we'll even run this program directly off of it without any further software. And that's the calloc program, read directly off of the MS-DOS formatted disk. We can take a directory of our A drive. We've got some blank space. Let's copy the calloc program onto the GCR Commodore 128 formatted disk. Now pip works destination equals source, kind of like in BASIC when you said A equals 6. So the value of 6 is assigned to A. It's similar with pip. Drive A equals the value of the program in B. So now if we look at it, here it is on the Commodore 128 formatted disk. And now we can run it directly from the Commodore 128 formatted disk. With the MS-DOS emulation program, you're not limited to the pip command for copying files over. You can use whatever is your favorite CP/M utility for copying files, such as Dave Rand's new sweep program. It's an easy one. It was very popular in the 1980s. So if we just go down, we can just copy it to drive A, just that simple. There it's done. Let's exit new sweep, take a directory. There it is. Of course, as mentioned before, the MS-DOS emulation program allows you to use an MS-DOS formatted disk directly in your favorite CP/M applications. So let's open up a text editor called VDE, and let's just write a simple text document and save it directly on the MS-DOS formatted disk. Okay, let's save this, and done. Let's take a directory and let's look at what I wrote. Terrific. Now let's walk this floppy disk over to our PC. Let's open up drive A. And there's the file we just wrote. Let's open it, double click. And there is our message. And that's how we can transfer files from the 128 to PC and from PC to 128 using the CP/M operating system. So let's put this disk back in the 128 and go into 128 mode. Now here we'll be using the Big Blue Reader program to read our MS-DOS formatted disk. So let's read the directory from it so that we can be ready to copy it over. Great. So the first one is our Commodore 128 program. Now we can use this program to transfer programs for any other Commodore computer, really. So our destination is our Commodore formatted disk, and we will rewrite the name, because in MS-DOS we were limited to 8 characters. We're going to expand it up a bit because with a Commodore computer we can do it. And comma P because it's a program file. Great, that's done. So now if we hit run, stop, restore, let's take a look at the directory of the Commodore formatted disk now that we've transferred the file over. There it is. So we'll run this first program. Voila, just like that. Of course, we can use the same method to take programs from a Commodore formatted disk and put it onto an MS-DOS formatted disk, and we can put it into the PC that way as well. Alternatively, if you don't want to mess around with different disk formats, you really don't have to do so. There are alternatives of getting files and programs onto your Commodore computer, such as using a dial-up modem, just like back in the days of the 1980s when you just plugged it into your Commodore computer, plugged the other end into your telephone service. And if your PC has a modem, you can do the same with that. Or, if available, you can dial up somebody else's computer. Imaging without the GreaseWeazle. Now perhaps you don't have a GreaseWeazle, nor have the required components that allow the GreaseWeazle to work, namely the GreaseWeazle, the floppy disk drive, the power supply for the floppy disk drive data cable, or the USB cable, or a substitute or a similar device such as the GreaseWeazle to allow you to make a floppy out of an image file, but you would still like to have a floppy disk containing the contents of a floppy disk image. Enter CB/M command. Now this program was designed to mimic the Commander style programs that were available in MS-DOS back in the day. So really it's an easier way to copy files back and forth between floppy diskettes. But in this case, we can actually use it to create a floppy disk containing the image, a D64 image in this particular case. So we have, once again, the source diskette is in drive 9, the target diskette is in drive 8, and now we are applying the image of this file, this D64 image, to the target disk. I know this might appear a little bit confusing because I have drive 8 on the right and drive 9 on the left, but it's still working nevertheless. Now this process can be somewhat lengthy. In this particular case, a single-sided floppy diskette image will take about 8 minutes with 2 Commodore 1571 disk drives. So let's just take a minute to keep one thing in mind about disk imaging using only floppy diskettes and the CB/M command program. Due to the overhead of the various disk image formats, your source diskette must be of higher capacity than the target diskette. For example, if you want to image a single-sided diskette, the D64 image must be stored on a 1571 or 1581 formatted disk. A 1541 disk has a maximum capacity of 664 blocks free when formatted, but a D64 image file requires at least 689 blocks free on the source floppy diskette. So what does that mean? If you want to image a D71 image, for example, onto a 1571 formatted floppy diskette, you must use a 1581 floppy diskette in order to contain the source disk image. So we can think of it this way. If we want to have, let's say, a 1541 disk to be written, let's always think that you need a drive one better than the one you really want to have the image for. So if you have a 1541 image, you have to use a 1571 formatted double-sided in order to contain the source image. If you want a D1571 disk to have the data from a disk image, you need to have a 1581 drive. If you want to apply a 1581 D81 disk image, you have to have something of higher capacity, such as an SD to IEC device, in order to make that happen. Just something to keep in mind when planning your disk imaging needs. Now, getting back to CBM command, skipping ahead to near the end, we see that it's about to complete the image transfer. And there we see on the right side the result. So let's exit, go to 40 column mode, and take a directory and see how this looks. Excellent. Well, let's see if this runs properly. Run Planet Duel 128. Perfect. Exactly how it should be. Well, there we have it. We have successfully met the challenges and broke through the roadblocks to computing like it's the 1980s. Of course, the solutions presented in this video are by no means comprehensive, but it is designed to demonstrate that there are mechanisms available to allow us to get the best use of our beloved Commodore systems. We didn't even really need to travel to the 1980s to do it either. Happy computing! May you enjoy your Commodore computer while you compute like it's the 1980s. Here are some must-have resources to help you to get the best of all three modes of your Commodore 128 computer. First of all, the Commodore 128's Programmer's Reference Guide. Next, for CPM mode, Digital Research's CPM Plus User's Guide, Programmer's Guide, and Systems Guide, all rolled into one. And finally, for the Commodore 64 mode, the Commodore 64 Programmer's Reference Guide. Thank you for spending this time with me. I appreciate your viewing this video. I especially appreciate the 33 subscribers to this channel as of the time of this posting. Why not click that subscribe button yourself and become the next one? I promise it costs nothing to try. Also, please leave this video a like, make a comment, and turn on notifications for my next video.